I welcome you to the first lesson of PH110, and the first topic is units and measurement. So in this lesson, I will introduce units and measurement, which is the first topic in PH110. So to start, we'll define the term physics itself. So we have to define the term physics. So we'll define physics. So we'll simply say physics is the study of nature and its laws. So that's the definition of physics we can give: study of nature and its laws. So what you must know is that most of the events that occur in the universe are governed by laws of physics. For example, falling of an apple from a tree, when you throw a stone upwards, it will eventually come down. Even the orbiting of planets around the sun, that is all governed by laws of physics. So I would find it as the study of nature and its laws. From that, we must know how physics and mathematics are related. Physics and MA. So in physics, in order to be able to explain these laws of physics using equations, we must have some basic knowledge of mathematics. So we must have some basic knowledge of what? Algebra. Rather than that, trig. Apart from trig, even calculus. So we must have some basic knowledge of these: algebra, trig, and calculus, so that we can be able to explain properly these laws of physics. So from this, we can conclude that actually mathematics is being used as a language of physics. So that's what we can take from that. Then we should talk about what? Units for measurement. So units that are used now for measurement. Units for measurement. Under this part, you should know that these laws of physics are expressed in terms of physical quantities. So the laws of physics are expressed in terms of what? Physical quantities. Now, what are these physical quantities? So physical quantities are simply any quantities that can be measured and expressed in terms of laws of physics. Any quantities that can be measured and expressed in terms of laws of physics, those are the ones we call physical quantities. For example, we can talk about mass, length, and time. Those are physical quantities. So what we must know is that a physical quantity, let's say Q, should be written in the form of N multiplied by U, where Q is the physical quantity, N is the magnitude, and U refers to the units of the physical quantity. So N is simply what? The magnitude. This is the magnitude. Then U, we are referring to units. That's it. And Q, that's what? A physical quantity. For example, let's say a physical quantity which is mass equals to, so we are writing this in that form. Mass equals to, let's say we are using 10 as the magnitude or size of the physical quantity, then multiplied by G, or simply 10 grams. So if we say mass equals 10 grams, we have expressed a physical quantity in that form. That's it. Then what we must know is that these physical quantities are divided into two major categories. So we have two major categories of physical quantities. So we have fundamental and derived quantities. These are the two major categories of physical quantities: fundamental and derived quantities. So let me start with fundamental quantities. So fundamental quantities, these are simply physical quantities which are independent of other quantities. This simply means that they are not obtained from any other quantities, but they simply exist on their own. For example, we should talk about what? Mass, length, and time. So these are examples of fundamental physical quantities which are not derived from any other quantities, meaning these quantities exist independent of other quantities. Then mass is measured in what? We can say kg, length, meters, then time, it's seconds. So these units of fundamental physical quantities, they are called fundamental units. So units of fundamental physical quantities are called fundamental units. Now what about the derived quantities? So the derived quantities are simply quantities derived from other quantities. For example, we can form quantities by multiplying or dividing two or more fundamental quantities. Therefore, we can say derived quantities, these are simply quantities formed by multiplying or dividing two or more fundamental quantities. For example, we know that force is equal to mass multiplied by acceleration. So mass is measured in what? We know it's kg. Then acceleration, it's meter per second squared. So this force is a physical quantity. Now, what quantities form the force? So we have kg there, which is mass. So we have mass, meter, which is length. So we have mass, length, and that is second, which is time. So we have mass, length, and time being combined, giving us a force there. So we can say force is being derived from what? Mass, length, and time. Rather than that, we can have pressure equals to force over area. Okay, then some of these derived units have special names. For example, we say the unit of a force is Newton. So the unit of a force is Newton. So kg, meter per second squared, is simply newtons, named after Sir Isaac Newton. And we can give another example of pressure being equal to force over area. So we know that force is in newtons, then area meter squared. Therefore, Newton per meter squared is simply what? Pascal. So Newton per meter squared is simply Pascal. So you can say Newton per meter squared has a special name as well, which is a Pascal. So these are the what? Two physical quantities which we have, fundamental and derived quantities. Okay, then from there we can move on to something else. Let's move on to something else. Just do that. Okay, so let's move on to system of units. System of units. So a system of units is simply a collection of units which are chosen as fundamental and all other units are derived from them. So it is simply a collection of units which are chosen as fundamental and all other units are derived from them. So such a system of units which consists of fundamental units only is called an absolute system of units. So we can say an absolute system of what? Units. Why absolute system of units? Because it only contains fundamental physical quantities, no derived quantities. Remember, we have differentiated the two already, fundamental and derived quantities. So an absolute system of units only contain physical quantities which are fundamental. So I'm repeating, system of units simply refers to a collection of units which are considered fundamental and all other units are derived from them. In such a system of units is called an absolute system of units. Hope that's clear. Then we have some examples of what? Physical quantities in this system of units. So in most of the system of units, the quantities mass, length, and time are considered fundamental. So these are fundamental units in most systems of units: mass, length, and time. Okay, then we have some common systems of units. So we have some common systems of what? Units. We talk about the CGS system of units. Apart from the CGS, we also have the FPS system of units. And finally, we have the MKS system of units. So these are the three common system of units that we have: the CGS, FPS, and the MKS. Now, let's understand these three. So start with the CGS. So remember, in all these systems of units, we have mass, length, and time, which are the fundamental units. So the first one, CGS. C simply stands for centimeter, G, that is gram, S, second. So we have centimeter, gram, second. Centimeter, we are talking about what? That's length. Then gram, that's mass. Second, that's time. So we can say in CGS system of unit, length is measured in centimeter, mass in grams, then time in seconds. So that's it about the CGS system of unit. Just know what the letters stand for: centimeter, gram, second, length in centimeter, then mass in grams, time in seconds. Then the second one, FPS. So F stands for foot, P, that's pound, then S, second. So length is measured in what? In foot, or simply feet. Then P, pound, that is mass. Then S, second, which is time. So under FPS system of units, we are saying length is measured in foot, mass in pound, then time in seconds. Okay, so you can write if you can take note of that if you're writing. Then we have MKS. So under the MKS system of unit, M stands for meters, K, kilogram, then S, second. So meaning that mass is measured in what? In kilogram, length in meters, and time in seconds. So we have M, meters for length, K, that is kilogram for mass, and S, that is second for time. So hope that's clear. Then from this we can move on to the international system of units, or simply SI units. So let's also talk about the international system of units, or the SI units. So SI units, we can say this stands for International System of Units, or simply Systeme International de Units. Systeme International de Units. Okay, so the International System of Units is simply an extension of the MKS system of units. So we can say it's an extension of the MKS system of units. So this MKS system of units was simply modified in order to form the SI units. So how was it modified? So we know that the MKS system of units only consists of what? So it only consists of what? Mass, length, and time. Consists of these three, the MKS system of units. Now it was modified by adding 4 more physical quantities. So 4 more physical quantities were added. So what are these quantities? We have temperature. So temperature, apart from temperature, we have electric current, we have luminous intensity, or simply light intensity. Rather than that, we also have amount of substance. So if we count, we have 1, 2, 3, 4. So these units were added to mass, length, and time to modify the MKS and end up having a new system of units called SI units. So that's how the SI units were formed. And this system of units, that's the one we call the metric system of units, which is made up of these 7 fundamental quantities. So we're saying we're calling this the what? Metric system of units. Metric system. Yes, we are calling this one the metric system of units. Then we should know the units of what? Mass. So mass, it's kilogram, symbol that's simply kg. So mass, kilogram, k, small letter k, and g. Then length, it is meters, symbol that's m. Then time, it's second, small letter s. Don't use a capital letter. Then temperature, it's Kelvin, capital letter K. Electric current, that's amps. We use amps or simply amperes. So amps A. Then luminous intensity or light intensity, we use candela, which is C, D, like that. Then amount of substance, this is a mole. So we know that amount of substance is simply what? A mole, like that. So that's amount of substance. So I hope you have understood the system of units as well as the international system of units, how it was formed from the MKS system of units. So for this video, that's it. Hope you have understood. See you in the next video.